This is section 1.03 from Unit 1, Statistical Graphs. Today I am, as in you are the student, discovering how to read different types of graphs so that I can perform calculations using graphs. I will know I have it when I can read and interpret statistical graphs to answer questions about the data represented on the graph. The specific TEKS we're looking at for today is 9A. Graphs. Graphs are a visual picture that can be analyzed and help summarize information about the data. One of the graphs we're going to be looking at is circle graphs. So you can see here, circle chart, favorite pizza toppings. We have pepperoni in green, cheese in purple, orange for sausage, and then red for supreme. And notice how you have different percentages, different slices of the pie for the circle graph. A circle graph is a graph that uses sectors of a circle to display and compare categorical data. The size of a sector shows how the value of that category relates to the whole. The entire circle represents 100%. Notice how half of the circle is green, so that represents 50%. A quarter of the circle graph is purple, so that is 25%. And then you have other different percentages as well. To find the value that each sector represents, we're going to multiply the percentage of that sector to the total of the data. So we're going to take the percentage, and whichever percentage we're using for the problem, and change it to its decimal form to be applied with whatever population or whatever number we're dealing with from the word problem, so that we can understand how much of that population or of that number is represented by a certain sector of that circle graph. Okay, let's look at an example to understand what I'm saying. So for this example, a total of 213 students were asked about their favorite pizza topping. Use the graph to estimate how many students like sausage pizza. So I'm going to cover some of these things up and reveal them as we go. So first thing we're going to look at is sausage pizza. What is the percentage that picked sausage pizza in this survey? And we can see that from this survey, 15% decided on sausage pizza as their favorite pizza. Now, what do we do with that 15%? Well, we got to change it to its decimal form. So either you can divide them, 15 divided by 100, to get its decimal form. So that means 0.15 is our decimal form. 15% equals 0.15. Or you can move the decimal point to the left twice if you remember the shortcut, and you'll get the exact same answer. Either way, we're using 0.15 for sausage. Now, what we're going to do to get how many you've chosen for sausage, we're going to take the 0.15 and then multiply with our total amount of students that were surveyed in this word problem. So we're going to take 213 multiplied by 0.15. So I'll show you all that in the calculator. Multiply this by 213. And we get about 31.95 for our answer. Okay, so there's the calculator steps. Now, since we can't have 0.95 excuse me, of a person, we need to round it to make it make sense in the context of the word problem. So we're going to round it up to the nearest person, the nearest student, and say that approximately 32 students like sausage pizza. So 31.95 rounds up to 32 students to more make this answer understandable in the context of the word problem. So 32 students like sausage pizza. Okay. So for this you try, read the problem, go through the steps A, B, and C. First, find out what is the total amount that Patrick's family has to spend for vacation. What is the percent that they will spend on the meals? Find that answer out and then change it to its decimal form. Multiply the two and then you will get your final answer. Okay? Now, if you're on ClassKick doing this problem, you can move this box, check to see if you're doing everything correctly. Otherwise, when you type these in, it'll tell you whether you've got them right or not. And then you can just keep trying until they get answered correctly. Okay? So, at this moment, I would like for y'all to pause the video, try this problem on your own. Otherwise, I'm going to go through it and explain how to do this. So, Patrick's family has $5,000 to spend on a 1-week vacation. How much money does the family plan to spend on meals? So let's look at the pie chart at the circle graph. We can see the vacation budget has been split down to 1, 2, 3, 4, 5, 6 different pieces of the pie, of the circle. The meals is represented by this sector right here, which is 21%. Okay? So, let me recircle that, 21%. I've answered part B. We know that the percent that will be spent on meals is 21%. If we were to change this as a decimal, take 21 divided by 100, and we get 0.21. Now, what is the total amount that Patrick's family has to spend for this vacation? $5,000, which was stated in the word problem. Okay? Now, what we're going to do to find the amount of money that's going to be spent on meals, we're going to multiply these two. So we're going to take the total amount, which is 5,000, multiply with the decimal form of our percentage, 0.21, to get our final answer. So 5,000 times 0.21 will make $1,050. So, Patrick's family plans to spend $1,050 on meals for this vacation trip. That's how much they're going to budget. There's your answer right here behind the box. And that's it for you try number 1. Okay, another type of graph you're going to look at is called a double bar graph. It's where each subject has 2 bars on it that represents 2 different things. So in this case, you can see for Karate Kid enrollments, it's split up between boys and girls. Early spring, you have the boy signups, and then in blue, and then you have the girl signups in red or pink. And then you can see that for early spring, early summer, etc., all the way throughout. Okay. A bar graph compares categories of data with each other. A double bar graph is useful for showing how 2 sets of related data compare to each other. So in the case of the bar graph, we're comparing boys and girl signups for Karate Kid enrollments. So in this example, the double bar graph shows how many kids enrolled in karate. In which season or seasons did the number of girls exceed or equal the number of boys? Okay, so these word problems that you're going to get into, they don't simply just ask how many boys signed up in early spring. Okay, there's a comparison being made. There's an analytical comparison being made to kind of draw your eyes or draw your attention to a specific conclusion. Okay, so in this case, what it's trying to draw you to is which season or seasons did the number of girls exceed or equal the number of boys. So we're going to have to think about this a little bit. Exceed or equal means that the 2 bars have to be the exact same, or girls has to be more than the boys. That's what we're looking for in this bar graph, double bar graph image. So looking through each one of these, whoops, I'm going to pretend y'all didn't see that. Early spring, boys are more, so that one gets crossed out. Late spring, same issue. Early summer, I noticed that the bars are equal, so that's one thing we're going to consider. Late summer, girls exceed boys, so we're going to circle that. And then early fall and late fall, boys exceed girls, so that doesn't get taken into account. So, how many seasons did the number of girls exceed or equal to the number of boys? And in this case, there were 2 seasons that they exceeded or equaled the number of boys. Girls equaled or exceeded the number of boys registered. All right, so in this example, you have a bar graph. It's asking you for a different set of questions or a different question. How many seasons was the number of boys greater than the number of girls? Okay, so again, look at what it says. Greater than number of girls. So you're going to use those clues to pick the information that fits the question and then put your answer right here. Okay, so at this time, I would like for y'all to pause the video and try this on your own. Move the box to check your answer. Otherwise, I'm going to continue on and show you how to do this. So the double bar graph shows how many kids enroll in karate. How many seasons was the number of boys greater than the number of girls? Okay, so let's look at early spring. Early spring is one of them. Late spring is another. Early summer, they're equal. We don't care about that. So early summer, no. Late summer, girls are more than boys, which is not what the question is asking. So no, we don't consider that one. But early fall, late fall, yes. So we have 1, 2, 3, 4 different sections, 4 different times, different seasons that boys, the enrollment for boys is greater than the number of girls. So we have 4 different seasons. And then again, you could check behind the box to check your answer, but that is it. That's all for you. Try number 4, or 2, sorry. Okay, line plots. Line plots use dots to represent frequencies of data values along a number line. The total number of dots is equal to the number of data values. So we have a table of number of pets. Their names are irrelevant in this case. We're just trying to figure out how many had 0, how many had 2, how many had 1, etc. Because if you look through the table, you notice that a lot of those numbers repeat. So a different way of representing this data to get a clearer picture of how many people have a certain amount of pets is to use a line plot. So notice how number 1 has 1, 2, 3, 4, 5 dots right above it. That means 5 people have 1 pet. 3 people have 0 pets. 2 people have 2 pets. 1 person has 3 pets. And then 1 person has 4 pets. That's it. That's how you read a line plot. Okay, a survey in this example asks for how many pets own they. A survey asks students how many pets they own. The line plot shows the results. How many students has 2 or more pets? So again, these problems aren't just simply asking how many have 1 pet. They're asking for a group of people, a group of data, how many of those chose 2 or more pets. So 2 or more means that they would choose 2, 3, or 4. Okay, we'll look at that section to determine how many have 2 or more pets. So if we count the dots, 1, 2, 3, 4, add them all up, we get 4. 4 people chose 2 or more pets. That's it. That's it for line plots. Okay, so now it's your turn to try. How many students visited 3 or less colleges? So again, think about what that means. 3 or less means you're going to lump in 3 and then everything less than 3. And then you're going to put your answer right there in the box. Check, if you want to check your work, move that black box right there. So at this time, go ahead, pause the video, go through it, see if you can answer it. Otherwise, I'm going to continue on and show you how to do this. So how many students visited 3 or less colleges? So we're going to choose 3 and then look at everything to the left of it. Okay, so count the dots. 1, 2, 3, 4, 5, 6. 6 students has visited 3 colleges or less. Okay. Now, just to kind of show y'all a variation of this, if I were to say, for example, less than 3, we would not have included 3. I would have included everything to the left of it in my answer. So instead of 6, it would be 2. So again, it is very important that whatever you read in the word problem is what you're looking for. You interpret the word problems and its clues appropriately to get your correct answer. Anyways, that's you try number 3. Histogram. Looks like a bar graph, but don't be deceived. It is a little different compared to a bar graph. So, a histogram is a graph that uses adjacent rectangles to display frequencies or relative frequencies of quantitative data values. So in 1.02, we've talked about frequencies, frequency tables, frequency distributions. This is basically taking those and putting them into a histogram, into a bar graph looking graph that just basically shows the data in a different way. So in this case, so the numbers between 60 and 65, probably not including 65. So this is basically 65 and less. About 3 is the frequency for those heights of black cherry trees. Okay, so between 60 and 65, there are 3 trees. Between 65 and 70, there were again 3 trees. Between 70 and 75, there were 8 trees, and so on and so forth. That's how you would read a histogram. We're going to go through an example to better clarify, but that is how you would read histograms. All right. How many black cherry trees are less than 75 feet tall? Okay. So less than 75 feet means we're going to go to the left of 75. And again, 60 to 65, we have, that should not be 2. That should be 3. Yeah, so that's a mistake. So that should be 3 plus 3 plus 8. So 8, 9, 10, 11, 12, 13, 14. 14 should be that answer, but again, let me explain. So between 60 and 65, there were 3 about. Same thing with 65 to 70. And then everything less than 75 is to the left of this line right here. So that includes this bar. So we're going to add 8 to those are the 3s. 3 plus 8 means there were 14 black cherry trees that were less than 75 feet tall. That's it. That's how you read a histogram, and that's the answer to this example. Okay, now you try. How many people finished the race in more than 40 minutes? More than 40 minutes. So, pay attention to what the question is asking. It's asking for more than 40. So there's going to be certain parts of the graph you're not going to include. It has to meet this criteria. More than 40. At this moment, I would like for y'all to pause the video, try this on your own, label how much each bar has, and then determine which ones you include in your final answer. And then you can move the box to check to see if you did this correctly. So do that on your own. Otherwise, I'm going to continue on and show y'all how to do this. So how many people finished the race in more than 40 minutes? So here's 40. So we're going to include everything to the right of this line right here. So that means this bar and this bar. So now between 40 and 50 minutes, we have a frequency of about 6. And then between 50 and 60, we have a frequency of about 3. So 6 plus 3, I believe, should be 9. So that means 9 people finished the race in more than 40 minutes. And that's it. That's it for you trying number 4. Most of the problems that we're doing right now, it's basically just figuring out how do we read these graphs and how do we determine from the word problem what we're supposed to be analyzing. Simple enough. Okay, let's move on to stem and leaf plots. Stem and leaf plot is a table used to show the shape of the distribution of a data set. Okay, so again, all these different ways of showing the exact same data basically is just it's to get a different view that may reveal something about the data that you wouldn't otherwise see if it were in a table, in a graph, in a pie chart, in a stem and leaf plot, in a line plot, etc. It'll show you trends. It'll show you things that you couldn't have seen if it were only in, let's say, a bar graph. Okay, maybe a stem and leaf plot would have shown you a different trend. So, ages of contestants. The key 6/2 means 62. So the numbers that I'm dealing with for row 1, for example, is 17. Okay, and then 18. And then notice 18 is twice. Now, done with row 1, so now go to row 2. With row 2, I'm dealing with 20. And then 23, 25, etc., etc. And then you would just continue on throughout the table, the stem and leaf plot. Okay, now let's look at an example. And notice how they're all in order, by the way. Notice how they're all in order. For this example, how many people are 27 years old or younger? 27 years old or younger. So, on a stem and leaf plot, for this example, we are looking at 27 years old, which means we're going to look at row 2, or younger. Now, if we had an 8, a 28 in there, we would disregard that number. We only want 27 and younger. So we include the 7, the 5, the 3, the 0, and then everything before that too. So that means the 17 and the 18s. We count those up. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 contestants that were or are 27 years old or younger. Again, read the word problem. Determine what part of the data we're focusing on to answer our problem. And that's it. Okay, you try number 5, stem and leaf plot. How many recruits completed 25 or more push-ups? So look at the data set, determine where 25 is located or more, count those up, and then that will be your answer. Okay, so at this time, pause the video, try this out on your own, check behind this box to see if you did this correctly. Otherwise, I'm going to continue on and show y'all how to do this. Stem and leaf plot shows the number of push-ups completed by a group of military recruits in 1 minute. How many recruits completed 25 or more push-ups? So the or more means we're going to want more than 25. So we're going to locate 25 or more and only count the stuff that's above 25. So that includes the 26, 30, 32, 33, 49, 44, 48, and 51. I realize that those numbers are out of order. Okay, so be very careful about that. Actually, those numbers were out of order. It would probably help y'all if you had them in order, but because we wanted or more, it didn't really matter. They were more than 25, so that's okay. But let's say we had a 2 at the end of this. Well, then be very careful about circling that 2. That 2 would not belong. And instead, we would have to disregard it when we are counting. So just be very careful about that. So, anyways, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 recruits that were able to complete 25 or more push-ups. Again, let's check. Make sure everything is good. Yep, 10 recruits, as you can see right there. And that's it for You Try number 5. Okay, that's the end of 1.03 notes. If you have any questions, my name, my phone number and email are there. So just let me know if y'all need anything through those things. You can text me or call me on my phone. After 5 o'clock, I tend to respond less because that's when I'm off of work. But if it's important enough, I'll go ahead and answer it after 5. But email me, phone, whichever y'all feel more comfortable with. Okay, that's all I got for this lesson. Take it easy, y'all.